Welcome back to Blueprint Bootcamp. Today we're going to be talking about high school heroes drawing number 6, the clamping coupling. So stay tuned. All right, so today we will be looking at our clamping coupling, drawing number HSH-06 or BBTE-006, depending on how you've been counting. So let's jump on over to our drawing and let's take a look at what we're dealing with today. All right, so we take a look at our clamping coupling. This drawing is going to ask us to create this shape right here. And so it's not the hardest shape in the world. It's a cylinder with some cutouts done in it. But speaking from watching this be done in the tournament, a couple of things to notice is that we have kind of like a counterbore up on the top. But if we look at this piece down here, it doesn't happen all the way through. So I knew this kind of threw the kids for a loop a little bit when they were making this one in the tournament. Let's look over here. We are making our clamping coupling. It's a tier 2 drawing. We're going to be making it out of plain carbon steel with millimeters and grams as our units of measure. So all these dimensions you will see will be in millimeters. So I take a look at this thing and I'm going to kind of bounce it around a little bit. I would draw this shape first if I could. So circle 14 millimeters on the inside. I'm going to draw a outside circle with an outside diameter of 40 millimeters. We're going to draw this channel using the slot tool. We'll kind of trim away some stuff. This drawing right here, this measurement could be a little misleading. It's showing you 2 and 4, but it's showing you that it's centered 2 up, 4 total. So that's good to know that it is centered. We have those center lines of symmetry there. And that sticks out 10 millimeters from the center of that. So that's kind of how we're going to get our measurement. So I'm going to go ahead and draw this guy. From this view, you'll also see that we get a 13 millimeter spacing from center to where the center of that hole is going to be. And we'll kind of go about this a little different. I'll show you when we get there. We know that our counterbore lives 10 millimeters up from the center point here. It's 15 across with a 6 millimeter through hole. And again, this is where we see that 13 again. And when we go ahead and extrude that whole thing, it's only going to be 44 millimeters across. So final question, what is the mass of this part in XXX grams with a tolerance of plus or minus 1 gram? So let's go ahead and jump into Onshape and we will get started. All right, once you are into Onshape, we're going to make sure we change our units. So if we look at this menu up here, we'll say update our workspace units. I've already changed mine to millimeters and changed my weight to grams. So we'll say okay. I'm going to start on the front plane, selecting it, Shift and S, N to normalize, and P to hide my planes. I'm going to draw a center point circle using the letter C on the keyboard. That is 14 millimeters in diameter. I'll go ahead and press the letter F, and then a little quick tip. If you press F, that fits it to your screen. So we have 14 on the outside, or inside, sorry. We'll click another one, same central location, and we are going to go 40 on the inside. So 40 and 14. Next, I'm going to do a center point rectangle oriented off the left of this origin, but not exactly clicked on the origin. We're just going to go like this, pop over to the side, make that 4 millimeters, and then we'll switch to D for dimension to go from here to my origin. Needs to be 10 millimeters. And then I'll go ahead and just swap that guy out. And we're going to use M, the trim tool, to cut out everything we do not need. And now we can do Shift and E to extrude. We need it to be 44 millimeters. And we're going to click symmetric so we can kind of do some symmetry. And we can use that origin to still line up our hole. So we'll go ahead and accept that. And we have our overall shape. Now we need to figure out how we're going to put this hole here. So if we look, that 6 millimeter hole goes through all the way. Yes, it's a counterbore, but that 6mm goes through all the way. So from there, we can go ahead and just draw a sketch on this plane right here, Shift and S, and we are going to normalize that view. Again, we'll do a circle lined up with our origin, and that needs to be our 6 through, and we will dimension from here to here needs to be 13. So we have our set there. We're going to say Shift and E, remove symmetric, and we'll say, instead of blind, we'll say through all, and that'll cut out of both sides of that clamp. We'll say accept. Now this is where things kind of get tricky. We need this to have a cutout here, but I don't have a face that I can click off of. So I can click this plane here, and if I look at my drawing, it looks like that it starts, actually not from that plane, we'll start from my top plane, and we will offset a plane that is 10 millimeters above our top plane. And the reason we do that is because of that symmetry line. So we'll go 10 millimeters above there, and I can go Shift S into normalize, P to hide the planes, and again I will do a circle. Same thing here, except this circle is going to be a 15mm counterbore, and it's got to be the same point. So I can say concentric. I can make, oh, it's not going to let me pop that up. So I can use that circle and then make these two concentric to one another, and that'll give me that same drawing that I need. I'm going to say Shift and E and remove as a solid in the opposite direction. And so now we have that part like so. We'll say accept, turn off all our planes. We'll right click, assign material for part 1. We're going to pick our TTT custom library, and this needs to be plain carbon steel. We'll say accept, come over to our weight, and we get a mass of 345.183. When rounded down, we get our 345, which is exactly our answer. If we look over at our drawing, you'll see we have a tolerance of plus or minus 1. So you can do anything from 344 all the way up to 346 and still be correct for this drawing today. So pretty simple part at first until you kind of jump into it and that planes kind of mess with you. So great shout out to Toby for coming up with this drawing. It definitely was one that challenged the kids and kind of threw them for a loop. It seemed easy, like I said, and then got a little complicated if you didn't plan out your steps. So a couple of things that we've always talked about in competition from my students: take the first little bit of time and just read the whole print and figure out what the heck's going on. Because if you don't read those instructions, you're not going to know what you're supposed to do. And if you can just get yourself lined out and kind of figure out what you got to do, time isn't a problem anymore, and you can kind of lock in and get done what you need to get done. So that's going to pretty much do it for us today. I know I told you guys in the last one I was going to keep the same shirt. Got a little busy filming this right before I'm supposed to post it. We had a field day this weekend, and we were up early, out late, all of the above. So hope you guys are learning some stuff and practicing. And if there's some other types of models you guys want to see on here, feel free to leave me a comment below and I will see what I can do. So that's going to do it for us today. You guys take care. See you next time.